All right, so we're here on the Advent of Code again. So let's do it. We're on day 16. This was the beam, and actually I remember trying this back in December for hours, honestly, and recording the entire time, and I didn't upload it because I didn't get anywhere. A good thing is I've kind of forgot about it, so I can approach it with a new mind instead of using what the hell I was trying to do last time. But it's one of these reflecting problems. You have mirrors and stuff. Okay. Upon closer inspection, the contraption appears to be a flat, two-dimensional square grid containing empty space, mirrors, and splitters. The contraption is aligned so that most of the beam bounces around the grid, but each tile on the grid covers some of the beam's light into heat, converts some of the beam's light into heat. Okay, so that's for the plot. So we have a layout here. The beam enters on the top left and is heading right. Then its behavior depends on what it encounters as it moves. Okay. If the beam encounters empty space, it continues. If it encounters a mirror, it's reflected. If the beam encounters a splitter, the beam passes through the splitter as if the splitter was open space, for instance. Okay. And then if you do hit it head on, it's going in the two directions the splitters are pointing. Okay. So this here. Okay. So this will involve some... Oh, it's already here. Nice. Some degree of object management, I guess. So... we're going to need kind of like a game state, and we're going to need ticks, so that's going to be our loop. Okay, let's start by just making a grid. Okay, well, we already have the grid, thinking about it, so that's good. Let's do const direction equals an enum of up, left, up, right, down, left, and okay, and then let's make a couple of constants. So const vertical splitter, which is this. And then we have the horizontal splitter, which is a dash. Empty is a dot. And what do we have? We have the mirrors. Const. I'm going to say right and left mirror. Right mirror is the one that's pointing to the right. And then this is the left mirror. Okay. Oh, okay, so then we go, for now I'm just gonna say let x, no, var x, which is a use size equals 0, let y, which is a use size equals 0, not let, it's a var. Then what we're gonna do is we're just gonna go for 0 dot dot, let's say 10, so we kind of want to start off with our example where you go here and you split straight away and then you go down. Just like, let's say 5, so then we should see the covered stuff. And the question's asking about how many tiles there are that have been covered. Yeah, okay. And I guess if it reaches the edge, it terminates. Let's see. If the beam encounters this, yeah, for instance, yeah. Beams do not interact with other beams. A tile can have many beams passing through it at the same time. A tile is energized if that beam's at least passed through it once. And I'm guessing you kind of just go off into infinity and don't really care. So if we go here, there's a split. Okay, so we're going to need const beam, which is a struct. Oh, I can't really learn zig. Book? No. Zig. Learn. This one. Zig.guide. Structs. And we use that. Okay, so we just say it like this. So we say your x is a u size, your y is a u size. We must also say the current direction. And I think that's it. Okay. And we're going to need a list of them. So var allocate equals stand.mem.page, no, dot heap dot page allocator beams, which is a standard dot array list of beam dot init with the allocator. Okay, and these are the ticks. Did it say anything else about what happens after? So, I mean, after, oh yeah, so we finish whenever the beams all just exit. So this is assuming there's no loops as well, which I think the example says. Okay. We don't need these anymore. We do need that. We need, I think the allocator can probably stay const. So we start off with beams.append beam dot x equals 0 dot y equals 0 and direction equals direction dot right. Okay. So we go then for beams dot items beam, yeah. So for each one we're going to move in the direction it is going, and if it does, so what would happen is, to start with, you would be here and then you move to the right. That's one tick. In the next, in this current tick, we spawn another beam that would go upwards and then the other one that goes downwards. Yes. And then in the next tick it would move down. So it'd be one to go here and another one to go here, and then that works. And we do also need to delete the beams if certain conditions are met, like if you go outside the boundaries. Okay. So for each one we're going to move, then decide what's going to happen. So we're going to go beam dot, let's move them, do we move them all and then decide? Maybe that's less error prone. Tick them all, and then, yeah, maybe that's a little bit better. Sorry, there's a bit of background noise. Okay. Switch on beam dot direction. Dot up. Then what we're going to do is we're going to go, oh, we need to do checks. Yep, to check. Okay, that's fine. If let's also do maybe is dead, so we don't have to delete it from the list. Oh, actually, an is active dot is, nope, is active equals true. And we go if beam dot, if it isn't active, we continue. So now we go, if it would put you in the outside of the bounds. So if we're moving upwards, that would be to do with the y, sorry. If y is equal to 0, beam dot y, beam dot is active equals false. And we continue. I'm not sure where this statement would go to. This continue statement. Zig continue keyword. Okay. Continue. Inline 4. Whatever that is. Okay, I'm so curious, what is this? For loops can be inline, this causes the loop to be unrolled. Ah, okay, cool. We couldn't do it here because it's dynamic. We could definitely do it here. It should be cool, but there's no need. I hope it does what I kind of want it to do. So after we check this and we continue, we're going to actually move it. So we're going to go beam.y minus minus. Is it minus equal 1? Because, yeah, okay. Okay. So let's do the same for the others. Up, right, if the x is equal to input 0 dot length minus 1, then we do this, plus or equal down. If the y is equal to input dot length minus 1, we go plus, and if it's left, if the x is equal to 0, then we do this. Okay. So that's to do with moving them. And after they have been moved, then we can check where they are. Okay, so if beam dot, actually we go input beam dot y, beam dot x is equal to empty, continue, nothing to see. Oh, actually, let's do a switch again. Input we're going to do empty. That's a continue. So that's kind of the only one that we can do the tilty things now to see where it would move to. If writes mirror, which would be a little, so if you're going from moving rightwards, you're going to be pointed upwards. If you're moving up, nothing's going to happen. That's correct, right? If the beam encounters a mirror, the beam is reflected 90 degrees depending on the angle. For instance, a rightward moving beam, do this. But if you go, if you come up, then you go point to left. If you go right, you go point to up. Yeah, okay. down, you go to the right. Okay. So in the right mirror, which pointing, then we kind of have to switch on direction again. Do we? Direction dot. So if you're going right, it's going to be pointing upwards. Then beam dot directions equal to direction dot up. There's got to be a better way of doing this, no? Okay. Right, and then let's do left. Well, actually up, right, down, left. So I've been doing it. So if you're going upwards and you encounter this, sorry, the right mirror. If you're going upwards, you should be pointing to the right. If you're pointing right, you should be pointing up. If you are coming down, you should be moving to the left. And if you are moving leftwards, you should be going down. So basically like swaps on this here. The left mirror, then... Oh wait, did I forget to actually change the underlying there? Oof, that's a good catch. There we go. Left mirror. Okay. I'm not even sure what this is doing. Do I need... No. Okay, that's correct. If you are moving up, then you're gonna go left. If you're moving right, then you're gonna go up. Where's that? Correct. No, sorry, it's gonna go down. If you're moving down, you're gonna go to the right. And if you are moving left, you're gonna go up. Okay, I just want to make sure I don't get this wrong. Okay, cool. Then we have the splitters. Okay, I'm going to change the input a little bit so that I can actually test this code for now. And then I need a which just does nothing. Yeah. Okay, so this is the ticks, and then this is what happens. And I'm going to take the print. Is there a print grid? There is. Should have that util. Okay. After each tick, let's do print grid. Oh no, this isn't like not actually gonna do much, is it? We're gonna do and print. Okay, don't need the snippet, thank you. X, Y. Beam.x, beam.y. Alright, let's run some code. Oh, I need to change that, don't I? Day 16. Okay. Cannot assign to constant. So I'm gonna need to do a thing of pointers. Take this, and then it's gonna annoy me. What's going on here? That's not right. Oh, this is going to be pointer there, pointer here. Oh, what's going on there? No. Okay. Yeah, I mean, I want the address of them, so expected type found pointer, or maybe just leave it like this. Beam dot cannot assign to constant. Zig array list of mutable structs. Can't modify array list as a member of a struct. No, that's not what I'm looking for. If you want a reference, write this. Okay, so var of beam equals to the address of items at the index. And basically anyway here I'm gonna do star. Oh, and I need to do it here as well. Nope. Star, and then star. Cool. And then same here. To actually mutate underlying structure. Okay. Switch must handle all of them. Does here. What if I just want to, it's just like empty, just nothing. Okay, so after 5 ticks, it moved to the right. Interesting. I wonder if it's hitting this left mirror and it's just being weird. Print. Actually, let's do unreachable. And then we should definitely have some guarantee. So it's not coming into here. But it should definitely be mutating. So let's print. Oh, also it's only doing it once. Whereas this does it 5 times. Like so. Yeah, it's as if they disappear. No, it's 1, 1, 1, 1. Oh, it's the active, right? Beam inactive. It's definitely coming into here. It's not. Am I running? Question mark. Yes. Beam is not inactive at any point. I mean, I can only assume this, but okay, let's think about this for a sec. So the first one is empty space, and it moves to the right once. The second part is a left splitter, so it moves to the right once. That's there, and then it goes for the left mirror. The direction is right, so the direction will be down. Direction beam dot direction. Under, can that be stringified? Yeah. And then it never reaches because it hits one of the continues but doesn't actually change the is active. So let's just set some branches here for us to see what's going on. Okay. Nowhere. Also, beam isn't inactive, so not sure what's it's continuing to. If it's empty space, continue. I mean, oh yes, of course. It's why my print statement is that's wrong, because obviously we continue on empty space. So it goes right, down, 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 down. So yeah, cool, that's all correct. Never mind, we did fine. Being inactive, am I running? Length, you're all good. Okay. So that's great. Now we must work with the splitters. Vertical splitter. What's going to happen here is the current beam is going to go up, but first of all we need to check once again switch on beam dot direction, and I need switches again because I need to do direction dot up, comma direction dot down. Then you can continue. Does that work? Yeah. Else, should we just write it? Yeah, let's just write it in case, you know. Left direction, right. We're going to do the same thing, where we're going to go beam dot star dot direction is going to be direction dot up, and then we're going to spawn another beams dot append. I'm going to try that. Let's just put some spaces here. Oh, it doesn't like it. Okay, fine. We're going to append beam at the current x of beam.x, beam.y, and the direction is going to be down. Okay. Oh, not delete around, yank around. Horizontal splitter. Left, right, you continue, up, down. So if you're going horizontally, you're coming down. I'm just going to send you the current beam to the right and the other one to the left. And then after that whole ordeal, we should have some fairly good idea. Let's actually have flag here, let var beam moved, which is false. And if we get past here, we're going to go beam underscore moved equals true. And down here, we're going to go say if the beam, if it hasn't moved, we break. And this just turns into a while true. And we're going to need another thing for this, which is going to be some encoded variables. So this just cares about the number of tiles that have become energized. So we're going to go var tile set, which is try standard dot hash map. Oh, is that so many things? Auto hash map, there you go. That's what I want. So I want the key to be a U128, and this will just be a boolean. Now you're going to initialize with the allocator. And we're going to have a function called get encode coordinate, which is going to have an x, a u size, a y, which is a u size, and a u128, which is going to return the x shifted 64 times. Ored with the y, I think. And through every time you move, every time you move before you try and do something, we're going to try underscore set dot tile dot underscore set dot. What's wrong with you? Why don't you know what this is? Underscore set dot. Oh, do you not take the try dot set dot initialize allocator? Oh, I think that was it. Dot init. There was no try. Dot put. We're going to do try, and it's going to be an encode coordinate. Beam.x, beam.y. What does the compiler say? Oh, and true. Type U6 can represent each type of U64. What am I doing wrong here? I'm sure that did. Oh, as 128, yeah, that was it. As 128, do this, and then you're gonna do as 28 this. Like this. Come on, bro, what's wrong? Oh, it's a singular bar. A lot of beams still active, which is not good. Did I? No. Actually, we might just have to do something else. Where we go? Const ticks. Let's say like, just do 10 million. 0.ticks. An underscore there, and you need a 4. Then we're going to print part 1, which is going to be tile underscore set dot count. So we're just going to run that 10 million times. Should be a lot quicker than this. Let's run it 1,000 times. Wow, even 1,000. It's slow. Because we probably just end up spawning so many tiles. 10? Give me 20. 25. Give me 50. 45. Give me 60. 45. Oh yeah, we're not actually counting the very initial one, which we should be. 0. Okay, well, we're getting the right thing. Can we do 100? Yeah, we can. Yeah, I mean, the thing is, there's a lot that has happened already, so we're going to need a ton of kind of memoization here, right? Because you could have circles where you split and you continue to split and stuff. You could have circles where you just have massive loops. Okay, well, let's try it. Oh, of course, it's massive. So, I mean, if we run it for 100, yeah, that is nowhere near enough, is it? Run it for this long. $68. Really? And you did save, and you are doing your thing. 68 is so low. Yeah, of course. 68 doesn't even begin to cover it. Oh, it's because the very first one is a thing going down. So maybe we should swap the actions and the tick. Right, we should swap this ordering, where we choose action first, and then we do tick. Yeah. We do need to change that. That goes into the else. And then we do the tick, and then we do that. Okay. That's interesting. Okay, print. Let's do print x, y, direction. Okay, what's that say? So it goes, starts at 0, 0, then it goes 0, 1, 0, 2. Oh, it gets stuck on the splitter. Because, did I do a continue? Yeah, else. It's gonna have to replace these to be else's. And this here too. Okay. Let's do 1,000. Huh? What? If I do 1,000, that dies inside a bit? Why? At beam.direction. Oh. Beam.append. No, that should be okay. Right? So you're going down, you're not splitting, then you're turning right, then you are splitting. It's kind of strange. If I do 500, do you crash as well? It does. And why do you crash? I mean, let's print that and then see what happens right before it crashes. Segmentation fault. Is it running out of I mean, this is a stack allocation, so maybe I need to do try allocator dot not alloc dot create. Yeah, it is the create. Okay, I think I will try that. We're gonna go var new underscore beam equals try allocator dot create. I feel like I'm running out of stack space or something, but that would be a stack overflow error, not this. So maybe that's not correct. New beam dot equals 0, y equals 0, new underscore beam dot. Oh, actually, you need star, don't you? Star dot is active is true. Dot direction equals a direction down. Okay. And this is when you're going left, right, and you have a vertical split. Okay. What happens now? Okay, so it seems like it was that. We were running out of stack space or something. Let's do 5,000. Seg fault again. Seg fault again. On beam.direction. Again. Don't actually know what's going on here. Yeah, it does segfaults. Why? I'm not freeing any of the memory. Invalidates element pointers if additional memory is needed. I mean, is that what's happening? That's so strange. 57 is also just so incorrect. Right, 57 has to be just completely wrong. Okay. So it does this, and then another, oh. What is this? Oh, okay, well. Dot x, beam dot y. Okay. Okay, let's change it to 500. Still segfaulting on me. Which I really don't understand. Segfaulting when appending an index member. Root cause is this. Okay, append is transformed to a pointer within the function array is expected. I think it's this here. Doing an index. Yeah, the index items. If you happen to expand the list right at this second, then you're a bit screwed. There are various open issues that cover this foot gun. Hidden pass by reference, yeah. Foot gun, hidden pass by reference. Yeah, this is exactly what I'm dealing with. Which shows different treatments. Okay. Yeah, this is all a lot, actually. Okay. What do you do then? And it has to be pointers. Pointers to beam. And then you then have to be an address to a beam. And then I can do beams.items beam, and you are now an address. Static pointer const. Sure. Cannot assign to const. No, go away. Okay, expected type, beam found const. Do I need to do this create thing again, maybe? So if I create it using an allocator instead, maybe it won't be so annoying. 0, 0. Okay. So let's just change new beam to be first beam, and then you are going to append first beam. Local variables unmutated. You sure about that? Oh, what else? Do you compile? No. I don't actually think I need an allocator anymore, to be honest. But we'll keep it, and then we'll change it if we need to. Okay, yeah, that fixes the issue. Wow, that's interesting. I actually want to save this for later use because I bet it's very useful. Can you do 1,000 now? No, it's still seg faulting. Why? Why are you seg faulting? Surely this is even the pointers, right? Come on. Yeah, just seg faults. Memory issue, memory issue. Oh, it's actually faulted a weird address, beams.item. .items. Zig array list iterate. Maybe there's a safer way to iterate over stuff like this. To slice. To not. None of this looks great. This was also 5 years ago. Zig array list. Let's see. I mean, okay. Array list iterating over items causes seg fault. No, that's not the one. Oh, this isn't array list values. Note any integer greater than this. Yeah, this is asking about this, but okay, so this guy is doing this, appending some stuff. This is a strange bug. Try debugger. Sure is weird. Yeah, and I definitely don't need to use an allocator here. What's going on the items? Seg faulting the items. That's really strange. Seg fault when iterating array list. None of this. I mean, we're back to here. Let's have a look at this. No. Mm-hmm. Mm-hmm. I mean, what I can think of is to just recreate the list, to be honest. To just do it each time. So yeah, okay, let's try that. It just looks like such a terrible way of managing memory, but ugh. Okay. Let owned var owned beams equals beams dot to owned slice, and then we can easily do beams dot. It did say, does it make it unnecessary? Safe but unnecessary to call. Okay. So we're gonna do, and we're gonna try the owned beams. Owned beams. There we go. And we're gonna go and say beams dot init again with the allocator. If it isn't active, we continue. If it is active, we go beams dot append, and we don't iterate on them. I guess that's the problem. We're appending stuff to a list that we're currently iterating through, which maybe isn't great. We're gonna append the pointer of this beam. Then we should be good. What? Oh, okay. So I guess I can go beams is equal to standard dot array list star beam dot init with the allocator. It looks promising because it hasn't crashed yet. Let's do a lot less ticks, you know, just 100. Okay. 246 looks good. 1277. 5,000. 6,000. I'm doing it incrementally because I don't want it to just run forever. Okay, we're reaching a good point. 6857. I know this is kind of an ugly way of doing it. It's really slow, and the reason it's slow is because we're going in loops, right? If you don't need to do the puts each time, for example. Oh no, 6921. Let's go up to 800 and kind of think about what we should do here. First of all, we should remove these allocations here on the recreation of the beam. What we can do we would have to create some level of caching, which we 100% will need for part 2, I think, for basically where you've been. You're going to have to create a level of caching that will tell you, okay, there has been a beam through here that goes up, that goes in the same direction in this exact same tile. So it's actually very, very similar to day 15, where we had kind of the exact same thing, actually. Still waiting for it to finish. In the meantime, we can make the changes necessary here to go ahead and say const, actually maybe var, we can just say var new beam equals beam like this. And that should be good. We are doing mutations. We're doing, I mean, what can we reduce here? Yeah, the amount of iterating you have to do is kind of silly, and each time you have to recreate an array list, which is not great. Okay, well, difference in 700 and 800 is a lot, so let's continue waiting for it to finish. Still waiting for the solution to come by. Wondering if, okay. Turns out that the 6921 was actually fine. No need to wait any longer. Okay, the process is kind of crashed. How much memory do I have? A chunk. Nice. I'm actually curious now though, because I've changed it to these allocators. So if I run, okay, missing struct field X. Oh, okay, so you definitely want this. What is active equals true. Let's fix some of the problems we have first, and then we'll move on to part 2, which I'm sure is also quite difficult. Now the direction here is to the left. Yeah. Found const. So let's do var. It's never mutated. Maybe if I do x equals new beam.x, I mean that makes the linter kind of happy. Cannot assign to constant. Oh yeah, do I at this point even need for it to be pointers? Because remember, like, we're never actually going to change them, because we are no longer mutating memory and stuff. So let's fix this up a bit. Try beams.append beam x is 0, dot y is 0, dot is active is true, dot direction dot right. That's the first beam, and we're kind of, yeah, I mean, we are mutating. Difference, maybe, do I need these anymore? You know, because, oh, it's 2 own slice, so I think it's fine. So this here and that there. This. Okay. We good? I think we're good. Cannot assign to a constant. Oh, here I can actually go over the length and beams.length index, and we can go var beam equals and beam at the index. Yeah, but now you just don't work. Oh, is it this? No. Okay, let's change a lot of stuff back. To go here, 0 to 9 beams at length, the index, const beam equals on beams at the index, and we're going to do an at to give us a pointer. Beams that depend. That's already a pointer. Don't need you to be a pointer, don't need that to be a pointer. Expected type found. Yeah, okay. Yeah, but now it's not. Okay, yeah, we do need pointers because we need to mutate stuff. Yeah, okay. Beam here. Okay, what else do I need to change back? Okay, let's do the address there. The address here. And this is good. No? Oh, the at there. Okay. First beam. So we're gonna have to do this stuff again. Point it to the first beam. Found a constant with the new beam. Did we? Oh. Change it to a var. That is still giving me like wildly incorrect ones. Okay, let's just do a lot of undoing. And I think this one gives us the right answer. Let's just double check. So we got 6921. We'll wait a little bit. I think actually no, 700 was enough. Let's do 650 actually. That was pretty quick. Oh, and we're still using the allocator though. Like this has to be terrible. 6920. 660, something like this. Yeah, this is yeah, okay, now that's back to being correct, but really bad. As you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to a nearby control panel. There's a collection of buttons that lets you align the contraption so that the beam enters from any edge tile. And heading away from that edge, you can, hold on. Oh yeah, sorry, I just got distracted. Okay, there's a collection of buttons that let you assign the contraption so that the beams enter from any edge tile and heading away from that edge. Okay, you can choose either of two directions. If the beam starts in the bottom right corner on the, it can, wait, any edge tile. The beam can enter from any edge tile and heading away from that edge. You can choose either of the two directions for the beam. If it starts on the corner, for instance, if the beam starts in the bottom right corner, it can head left or upwards. Okay, so there's those edge gates, but if you start on the bottom edge, you need to go up, etc, etc. So if the beam could start on any tile in the top row heading downwards, any tile in the bottom row heading upwards, any tile on the leftmost column heading right. Okay. And you're seeing to produce lava, you need to figure out. Okay. Cool. So basically, I'm very much going to need some caching because this is too slow. So I need to make part 1 very fast. And after that, yeah, then we can start thinking about part 2. So the reason it's slow is because we are continuing to do things even if a beam has already done them. And I think we can avoid splitting this many times. Yeah, I think it's the fact that the amount of beams grows very quickly. So if we avoid that by doing a check beforehand, also this allocation just looks so wrong to me, but whatever. By first checking, and what we're going to check is we can check if a beam has been split here. But also the amount of ticks just seems so wrong and so arbitrary, so I think that maybe the better way of doing it is we check the position of beams that are active, like from a map, and we say, okay, has there before been a beam with the same x, y, and direction? If so, set it to inactive. Set it to inactive and continue. So what this should do, or actually just continue. What will this help? This will help because we're not doing multiple of these for the sake of doing them. Yeah, I think it will kind of like keep pushing the curve down. So let's try that. So we're gonna have coordinate to direction. It's gonna be an auto hash map between a U128 and a direction. Okay. And we can start off by, actually no, we can go through the ticks. Oh wait, that kind of helped with the ticks, didn't it? Because if, basically, it's going to be active and then this global cache, if there has been, then we're going to append at some point, you're going to reach the point where you're going to have so many loops that either all the tiles have been through. Oh yeah, so, okay. Yeah, okay, so we're going to go while beams dot count dot items dot length is bigger than 0, and we're no longer going to need the ticks. Yeah, that's it. So we're going to do it each time you start. We're going to do try course to direction of encode the coordinates of beam.x and beam.y. We're gonna give it exponent.put. We're gonna give it beam.direction. Okay, nice. If we can get, we're gonna go const encoded coordinate, which is encode coordinate. I think the compiler would just extract this anyways, but you know, encoded coordinate, no, encoded coordinate. Dot question mark, do I use this? D if D equals beam dot the current direction, then we can continue and never append to the original beams. Sounds good, I think. Then the tile set will continue at the bottom there. The map between this and direction. No, we need a little bit more, I think. Because the keys, yeah, no, they need to all be in the same key together. Yeah, so I'm going to need like a different encoding function. It's going to be encode chord with direction. And actually, I'm going to set direction to have okay. U size, Y, U size, and then direction, and then you're gonna have a U. Can I have a U? What is 128 plus 16? 144. Sig int types, primitive types. Yeah. Wait, really? Integer literals. It can go up to quite a bit. U128. Can I just do one U144? I wonder if it actually cares. If I do 128, nothing. U144. Struct, no, enums, and I need that enum to contain some value. I wonder if it can even do 530. So this would be U2. Which is equal to 1, which is equal to 2, which is equal to 3. Okay, so we're gonna go return basically this, but U130, you're gonna shift over 66 times. You're going to shift over twice, and you're going to be ORed with direction dot int from enum, yeah. Wonder if you compile. Yeah, it actually lets me use arbitrary integer types. That's fun. Okay, not the tile set actually. U30 boolean, so that's a set. chord direction set dot put encode beam with direction true. Incompatible types boolean and something else. I mean, if it has it, then we just continue instead. Well done. No. Encode chord with direction. Beam dot direction. Coded chord. Alright, that's made it a lot faster and given me the correct answer. Good, so I'm glad that works. Next thing is to, wrap this in yet another loop. Wow, I'm tired. It's been, how long has it been? Like an hour or so? This is very non-modular code, but okay. You can fold this. I think in a way having like such nice folding features with Vim, like isn't great because I can do stuff like this, like hide away complexity, when sometimes shouldn't. But anyways. We have the coordinate set, we have this tile set. This should all kind of be wrapped. So this is part one. Yeah, I should also organize it so that's, you can have, yeah, okay, let's actually do it. Tiles, let's just go round, I don't know. Tiles covered. Take in a grid like that. Let's say constitute, and you're also going to have first also an allocator, stand.member.allocator, the input, and you're going to have a beam, which is the initial beam, and you are going to return to me a usize. No allocator. Var beams is very much here, takes in from the allocate. The first beam is not created, but it is appended here. Initial beam, and we can do a pointer star to the beam. Allocate encode coordinates, do this, blah 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 blah. No longer print, but turn tile_set.count. Now I think if I do this, and then I can delete this hopefully, and I can go const part1 tiles covered, and the input in the initial beam is going to be the first beam, part1. Expected usize found. Okay, so you can be this, and on 13, oops, I can add the little try keyword. Okay, good. That's part one. Now, for the rest, we're going to need to go. So we should do corners, like all the corners, and then do the edges. So we kind of get rid of that edge case straight away. Corners, corners, corners. Yes, and you should kind of, I think we should even unravel those. We can go top left down, top left going down. Okay, hold on. First of all, I kind of would love to see if I can do this like this. Dot y equals 0. Dot is active is true. Dot direction is Let's get rid of u. Local variables not mutated. Great, so that's how you do that. And then for part 2, let's create 7 more of those. Top left, so that one's going right, top left down. No. Top left down, top right down, top right left. Okay. So that's both the left ones. This can be top left right. And then this is bottom left right, bottom left up, bottom right left, bottom right up. So top left down, top right input 0 dot length -1, input 0 dot length -1, down, this is left, bottom left, so dot length -1, up, bottom left going up, input dot length -1, and then so this is when bottom right, so it's input 0 dot length and length -1 dot length -1 -1 -1 left. Good. There we go. So we have all these, the corners, which will be, you know, getting rid of these edge cases. The ironic part is that it doesn't even matter, right? Because the likelihoods of it being one of the corners is kind of low. We're gonna go var highest, which is a use size of 0. Oh, we should do, yeah, we should do an array list with all of them. So we're gonna go, yeah, there we go. I know what to do now. Var starting points, which is standard dots array list of beam allocator. Do I have to try here? No. Starting point. Okay, so starting points dot append top, left, right, try. I mean, I know this looks kind of ugly, but I think this type of logic just belongs unrolled like this, because what it does, top, right, down, top, right, left, what happens is that you no longer have any kind of edge case in a way, like in your loops, so you don't have to do much else. It's never mutated. Yeah. So you'll see that the loop will be so much more clear. And it's kind of obvious what's happening here, but I could be wrong, to be honest. But it feels better to get rid of edge cases and have slightly more dense code than have the edge cases be inside loops where it's much harder to debug and such. Now, if we go between 0 dot dot input dot, okay, so this is going to be the y, but dot length dot input 0 dot length, the x, I'm going to go if, oh, we're still going to have to skip the corners, to be fair. So if y is equal to 0 and x is equal to 0, and or, yeah, so we have to do 4 conditions here. Y is equal to 0. Oh no, I don't. Why am I doing this? We can just go between. Yeah, that's the whole point I did this. Just realized. -1, and now we're going to do try starting points dot append beam dot x equals x dot y equals y dot is active equals true dot direction. Oh no! What the hell am I doing? What the hell am I doing? Okay. Never mind. Sorry. Input dot length. So these are going to be the all of the left and right. Yeah. Okay. All of the left and right. So we're going to go try starting point dot append beam dot x is equal to 0. So the left hand side. Y is equal to y dot is active equals true dot direction equals direction dot right dot left with the x being input 0 dot length -1. So that's left and right, and now this is going to give you the top and bottoms. Y starts 0, input dot length -1. So if you're at the top, you're going to go down. If you're at this, up. Okay. For starting points dot to own slice initial, yeah, starting, which is a beam. Yeah. You're going to go and say if tiles covered with the allocator, tiles covered, allocator the input and the starting beam, which I could take a pointer to. Yeah. Is bigger than the highest. I think I have to do a try. Yeah, then highest equals. Oh, let's do const covered equals delete to this here. Covered is bigger than highest, and highest equal to covered. And we're going to do print parts 2. Starting is very much a beam. I wonder if I can change tiles covered to give you just beam. Right, and then we can just do this like so. And then it should be a copy. Where is this? This here. Beam set append. The initial beam, the at of the initial beam. Okay, let's not dwell too long on this then. Starting points, pointers. Let's feed you pointers then. Now, yes, you are a pointer, and that should just kind of work itself out. Oh, that's pretty annoying. So we're gonna do var rightwards equals this. Delete inside here. Var leftwards rightwards leftwards. And if I do the ampersand, then the compiler no longer complains. Delete inside here. Var downwards equals this. Delete inside here. Var upwards equals this. Like so. Downwards, upwards, and pointer, pointer. Okay, var. Okay. Well, that just can't be right. I mean, well, starting. Wait, what? That's crazy. It feels like I didn't even do something different. You obviously can't. And you're not getting the even beyond part 1. That's all the rights. I mean, they seem a little bit out of order, but where the axis to, up, it goes down, is, well, I mean, what is going on? The x is 0, the y is whatever it is, then we go to the right, or otherwise we go to the left. It seems to be being a little bit weird. Let's find x0. That can't be right. Without length y. That can't not be right, because you only have... You have so little. Like, where's the x, all the x zeros? These ones here, the rightwards ones. Something strange going on with this code. There are a lot of question marks. Yeah, tons of them. And we're appending starting point, the pointer to right. Oh, is this another very annoying problem? Of, you know, like null references and stuff. Could it be? Oh, that's just weird. Weird. Okay, let's take that one out. Let's put this one here. Let's have a look at the ones that go rightward. Rightwards. They're all there. And then as soon as I try and do them there, they have all vanished. Also, this doesn't make sense. What is this? Y equals 5 on... Oh no, this is on the very right side. But there's so many duplicates. Look at the amount of duplicates here. This is so strange. Really strange. I think this might be a stack problem because outside of the for loop, maybe they get deallocated and stuff. Okay. And I can't inline it. Yeah, I can't inline this for loop. I'd love to, but r dot y equals 0, r dot is active equals true, r dot direction equals direction dot right. L changed L. Replace u with y. Replace this with input 0 dot length minus 1 and a y. L and R. And let's get rid of it. Let's just do that for now. D D, U, U. Okay. Down. Oh, God. Okay. Brain is starting to fry. And my brain is starting to be fried. Okay. D, U. Let's comment that out. That looks much more sensible. Okay. I think we're good. Yeah, it was that problem where, but it's weird that it doesn't segfault there, actually. That's strange. Runs part 1 and is running part 2. There. It's hopefully correct. Oh no, it's too high. Really? Okay. Really thought I would do it. So what we get for this one, we get 52. Using screw rig, 51 tiles are energized. 51 tiles done. What did I get for the last one? 7594 maybe? 594. Is it off by 1? 94. Okay. I'm gonna leave it there. But taking into account that you pass in the starting point and to task covered, you put 0, 0. Ah, yeah. You should really put the initial beam dot x, initial beam dot y, 51. There we go, and let's try that again, and I'm pretty sure it was an off by 1 error. Yes, it is, so that means that this is the correct answer. Alright, happy with that, actually, quite happy with that. Did I feel stuck? Not really, it was a kind of grueling. I learned a fair chunk, just more things about lower level programming languages, things that you have to think about much more. So, for example, if you're using a for loop to allocate memory, you have to make sure it's not stack memory because it gets deallocated as soon as you escape the scope. Similar to Rust's borrow checker and stuff. As soon as you exit scope, the memory is freed. So you need to use an allocator because this stack frame will be lost. If you could inline it, that would be great. Which we actually can because we do know the length of the input. But this was good. I think my solution's fairly neat. There might be a lot of memory used, like this type of stuff. But again, yeah, I don't know if my data structures here, especially to do with pointers and copying and stuff, is perfect. Doesn't look great. This thing here might have been the biggest though. Like I was mutating a list whilst using it, which is obviously a bit weird. So you shouldn't do that. So I'll try and just remind myself of that a lot. Okay, thank you very much for watching if you still made it, and I'll see you in the next one.